Are you a Rockwell programmer ready to dive into Siemens TIA Portal? Or perhaps you're already experienced with TIA Portal, but now you're starting your journey into the fascinating world of Rockwell Studio 5000 programming? Then keep on watching, and I promise you, after finishing this tutorial, you will feel confident transitioning between these two giants of automation. Let's dive in. Hi, Hans Schreinemakers here, course instructor and content creator over at plcskilltree.com. Now, throughout my career, I have worked extensively with both Siemens and Rockwell PLC programming, and I've mastered a deep understanding of each platform. In this video tutorial, I will dive into the differences and the similarities in structuring PLC applications between Rockwell Studio 5000 and Siemens TIA Portal, exploring topics such as program execution and organization, tag structuring, data handling, and encapsulating control logic. By the end of this video tutorial, you will understand how to efficiently structure your PLC program for either platform, making it easier to transition from one to the other. Just a quick note here before we get started. If you are transitioning from Rockwell to TIA Portal, I would like to give you a helping hand. I have designed a free guide containing 5 easy steps on how to build structured PLC applications in TIA Portal. Simply click on the link in the description below this video and start your TIA Portal journey today. Alright, let's move on to the main event of today, Rockwell versus Siemens, a head-to-head comparison on PLC program structuring. In Rockwell Studio 5000, RS Logic 5000, particularly when using their control logics and compact logic PLCs, program execution is structured around tasks. Each task dictates how and when the PLC program executes. Tasks in Rockwell systems can be event-based, periodic, or continuous, and can easily be created by right-clicking on Tasks in the left tree structure of Studio 5000 and selecting New Task. Now here's a quick breakdown of the 3 different task types. A continuous task executes as often as possible, which is the default mode of execution. It runs continuously, and its scan cycle depends on how much logic is present in the task. The more logic a continuous task needs to process, the slower its execution will be. Only one continuous task can exist in a Rockwell PLC program. A periodic task runs at a fixed scheduled interval, for example 20 milliseconds, which can be specified right here. A periodic task guarantees that logic will execute on a strict time schedule, providing deterministic behavior. You can have multiple periodic tasks in a program, each with different time intervals. Finally, an event task is triggered by an event, such as a change in an access registration input, a motion execution, or a module input data state change. Event tasks provide immediate response to changes, and their execution can interrupt other tasks if configured to do so. In this example, I have created 2 periodic tasks, each with a 10 millisecond cycle. One task is dedicated to executing all logic related to equipment modules, while the other is used for executing logic related to machine modules. Siemens TIA Portal uses organization blocks, or OBs, as the backbone for program execution. OBs define the structure and control the order and manner in which code is executed in Siemens PLCs. To add an OB to your program, simply go to the Program Blocks folder, choose Add a new block, and then select the organization block type. There are various types of OBs, each designed for a specific purpose. Here are some of the most commonly used ones. The OB1 is the main program cycle which executes cyclically, similar to the continuous task in Rockwell. It continuously executes logic and is often used for the main program logic. It is also the only OB that is automatically generated when a new PLC device is added. Cyclic interrupt OBs range from OB30 to OB38, and they are executed at predefined intervals, for example every 100 milliseconds. This is similar to periodic tasks in Rockwell. Each cyclic interrupt OB is tied to a specific time interval, allowing deterministic execution at regular intervals. Next up, hardware interrupt OBs ranging from OB40 to OB47 are OBs that execute in response to hardware events, similar to an event task in Rockwell. For instance, if a module detects an error or a sensor signals a condition, the associated OB executes. Then you got your startup OBs, OB100, 101, and 102. These are executed during PLC startup or after a warm restart, and they can be used, for example, to initialize variables or to declare configuration bits and parameters. And finally, error OBs ranging from OB80 to OB87 are used to handle specific faults such as cycle time overlaps, hardware errors, or I/O communication problems. These OBs allow you to execute specific actions in response to various fault scenarios. So there's a whole lot of organization blocks in Siemens TIA Portal. But the most important one, the one OB to rule them all, is the OB1, the continuous task. This is where you will call your various program modules. Siemens PLCs are extremely fast, often achieving cycle times as low as 1 millisecond, which stands in contrast to Rockwell PLCs, where a 10 millisecond periodic task is considered fast. So if you're transitioning from Rockwell to Siemens, prepare for a noticeable increase in speed. In summary, both Rockwell and Siemens PLCs offer distinct methods for program execution. Rockwell's approach centers around tasks, including continuous, periodic, and event tasks, while Siemens utilizes organization blocks as the core of its execution model, with OB1 acting similarly to Rockwell's continuous task, while other OBs handle periodic and event-driven operations. Now that we've covered how programs execute in Rockwell and Siemens, let's explore how they are organized. Rockwell Studio 5000, or RS Logic 5000 as it's called for older versions of the software, organizes logic into 3 tiers: tasks, programs, and routines. Tasks determine the overall scheduling and execution of the logic. They control when and how often programs execute. There are 3 types of tasks: continuous, periodic, and event tasks. In this example, we have 2 periodic tasks that both run with a 10 millisecond interval. Inside each task, you can have multiple programs. In this example, the equipment modules task includes a program for a cooling tunnel, while the machine modules task contains programs for alarm handling, network diagnostics, and a machine state handler. Programs are essentially containers that hold routines and local data, allowing you to break logic into distinct sections for easier maintenance and better organization. Now, routines are where the actual logic, ladder diagram, structured text, function block diagram, or sequential function chart is situated. The most common routine is the main routine, which is executed by default when the program runs. Other routines can be created and called from the main routine or from other routines within the program. Routines don't need to have a globally unique name, they only need to be unique within their specific program. In this example, I have created 4 routines within the cooling tunnel program: a main routine, a configuration routine, a conveyors routine, and a cooling routine. Siemens TIA Portal takes a slightly different approach to program organization by using program groups and function blocks. Program groups are used to organize the various modules of your application, similar to programs in Rockwell. In the example right here, I have organized my PLC application by creating groups for equipment modules, machine modules, global data, and library blocks. Additionally, the equipment module contains a subgroup for a cooling tunnel module, while the machine modules have nested groups for alarm handling, network diagnostics, and a machine state handler. You can easily add program groups by right-clicking on either program blocks or an existing group and selecting Add New Group. These program groups are not automatically called or executed within the application. They are only used as folders for organizational purposes. So this is a difference with Rockwell, where programs are actually called automatically. Groups are always ordered alphabetically. The order cannot be chosen freely like with programs in Rockwell, which is a bit of a bummer. Now, what I normally do to order groups in TIA Portal in my PLC applications is assigning a number to the beginning of the group name. Like for example 00 equipment modules and 01 machine modules. In addition to program folders, PLC applications in TIA Portal can be organized using function blocks. Function blocks are similar to routines in Rockwell, as they hold the actual logic for controlling specific parts of your application. In contrast to routines in Rockwell, which only need to be unique within the program scope, FBs, FCs, OBs, and DBs in Siemens must each have a unique name. Taking a quick look at the cooling tunnel module in our example, we can see that the logic is organized by dividing it into a main block with the associated instance DB, a configuration block, a conveyors block, and a cooling block. Both Rockwell and Siemens have powerful tools for organizing a PLC program, but they implement and name them differently. Rockwell Studio 5000, or RSLogic 5000 as it's called for older versions of the software, uses a three-tiered approach: tasks, programs, and routines, that typically has a flatter structure compared to Siemens. Siemens TIA Portal, on the other hand, organizes programs using program groups and function blocks, following a more hierarchical structure compared to Rockwell. It's not uncommon to see function blocks nested 2-3 layers deep in Siemens systems. Now let's explore how data is organized on both platforms. In Rockwell Studio 5000, you can easily create UDTs by navigating to the Data Type section in the Assets folder within the tree structure. Simply right-click on User Defined and select New Data Type to create one. Each UDT can include a wide range of Rockwell's primitive data types, such as a Boolean, a double integer, or a timer. You can also nest UDTs within other UDTs to create more complex data structures. In this example, I've created a user-defined data type called UDT conveyor, which is composed of a configuration area, parameters, a status area, a command area, and a fault area. Each of these substructures is built using their own user-defined data type. In Siemens TIA Portal, UDTs also provide a way to group multiple data elements of different types into a single structure. These UDTs are highly customizable, and they are used extensively to structure data in programs. In TIA Portal, UDTs, or user-defined data types, are created in the PLC data type section by simply clicking on Add New Data Type. In this example, I've created a UDT conveyor containing all the data related to a conveyor module, and a UDT cooling for all data related to a cooling unit. Each data structure is further organized into substructures, including configuration, parameters, status, command, and fault. Siemens UDTs support all basic data types such as booleans, integers, and reals, as well as complex data types like arrays, structs, and other UDTs. This provides a high level of flexibility when defining your module data structure. In summary, both Rockwell Studio 5000 and Siemens TIA Portal use user-defined data types, or UDTs, to help organize and manage data in automation systems. UDTs make it easier to handle complex information by grouping different data types into one structure. Siemens TIA Portal offers more flexibility with struct data types, which simplifies the process by not requiring separate UDTs for each substructure. In Rockwell, you need to create individual UDTs for each part, making it a bit more involved. Understanding these differences can help you create the right data structures for your PLC application. Now that we've covered how UDTs organize data in Rockwell and Siemens, let's move on to how these platforms manage data access. In Rockwell Automation, control Logix and compact Logix systems, data is typically organized into tags, which can be global, also called controller scoped, or local, program scoped. Global tags are defined at the controller level and are accessible from anywhere within the project, including any task, program, or routine. Global tags, or controller tags as they're also called, are created in the Controller Tags section of the Studio 5000 environment. Once created, they can be accessed by any routine, program, or task in the project without any additional steps. Furthermore, global tags are often used for sharing data across multiple programs or routines, such as status indicators, commands, or I/O data. In this example, a global tag structure called EM cooling tunnel was created using a UDT data type. It includes 3 conveyor structures, assuming array element 0 is unused, and 2 cooling structures, assuming again array element 0 not being used. Local tags are tags defined within the scope of a specific program, and they are not accessible outside that program. These are referred to as program-scoped tags in Rockwell systems. Local tags are defined in the Parameters and Local Tags section of a specific program in Studio 5000, and they are accessible only within the routines of that program. They are typically used to encapsulate data specific to the program's operations, enhancing modularity, and making management tasks, such as copying and pasting programs, more efficient. Siemens uses global data blocks, or DBs, to store and manage global variables. DBs can be accessed from anywhere in the PLC project, including any organization blocks, OB, function block, FB, or function, FC. Global DBs are declared independently of any specific block, and they are available project-wide. Creating global data blocks in TIA Portal is straightforward. First, under Program Blocks, click on Add a new block. Next, choose Data Block and make sure Global DB is selected as the block type. Finally, assign a name to the data block and click OK. In this example, I've created a global DB named EM cooling tunnel within the global data program group. This data block includes all the data related to the cooling tunnel module, containing 3 conveyors and 2 cooling units. The structures for the conveyors and the cooling units were created using arrays of user-defined data types. Global DBs can store simple data types like booleans, integers, or reals, or complex data types like structs, UDTs, or arrays. Now let's have a look at local data. In TIA Portal, local data is available for FBs, FCs, and OBs, and are handled through instance data blocks and temporary variables. When using function blocks, instance data is stored in an instance data block, and in this example, if we open the main program cycle OB1, you can see that the main function block for the cooling tunnel module is called in network 1 using an instance DB. This instance DB was automatically created when the FB call was programmed. By opening the FB and examining the block interface, we can see that the local data of the function block is divided into an input area, an output area, an in-out area, a static memory area, a temporary memory area, and finally a constant area. The input, output, in-out, and static areas are stored in the instance DB, and they are unique to each call of the function block. Furthermore, all variables defined in the static memory area are persistent across program scans, retaining their value from one scan to the next. On the other hand, variables created in the temporary memory area exist only during the block's execution, and they are discarded once the execution is complete. Temporary variables can be used in function blocks, functions, and organization blocks. However, static variables are only available within function blocks. Rockwell and Siemens TIA Portal each provide unique approaches to managing global and local data within their PLC systems. Rockwell differentiates shared and program-specific data using global and program scope tags, while Siemens relies on global data blocks and local data in FBs, FCs, and OBs to handle data across various scopes. Now let's conclude this comparison with a powerful finale by diving into how both platforms handle logic encapsulation. In Studio 5000, logic is encapsulated using add-on instructions, or AOIs, which can be found under the Assets group. AOIs allow for the creation of custom reusable code modules that can be instantiated multiple times within the program. AOIs can encapsulate both the logic and the associated data, allowing for reusability and modular programming. In this example, all control logic for a single conveyor unit is encapsulated within the add-on instruction AOI control conveyor, while all logic for a single cooling unit is contained within the add-on instruction AOI control cooling. By opening the conveyors routine in the cooling tunnel program, you can see that the AOI control conveyor add-on instruction is called 3 times in the application, with each call using a unique instance. Similarly, opening the cooling routine shows that the AOI control cooling add-on instruction is called twice, with each call using a unique instance in the PLC application. In Siemens TIA Portal, logic encapsulation is primarily managed using function blocks, FBs, and functions, FCs. These can be easily created by selecting Add New Block, located just below the Program Blocks folder. The key difference between functions and function blocks is that functions only support temporary memory, not static memory, so they do not require an instance data block. Functions are generally used for smaller logic segments that don't need static memory, such as a scaling block for a temperature sensor or a block that verifies the size of an array. Function blocks, on the other hand, do have static memory, which is stored in the instance DB of the block call. In this example here, I started by adding a library group to house all reusable functions and function blocks. Within this group, I created FB control conveyor to encapsulate all the logic for controlling a conveyor unit, and FB control cooling to manage all logic for a cooling unit. If we open the cooling tunnel conveyors function, you'll see that the FB control conveyor block from the library is called 3 times, each with a different instance data block. Likewise, if we open the cooling tunnel cooling function, you'll notice that the FB control cooling block is called twice, with each call using a separate instance DB. A key advantage of TIA Portal over Rockwell is that functions and function blocks can be modified during runtime. TIA Portal only downloads the changes that you make, not the complete application, and this download can occur while the PLC remains in run mode. Rockwell, on the other hand, does allow you to edit routines online while the PLC is running, but making changes to an AOI, an add-on instruction, requires downloading the entire application, which forces the PLC into stop mode. So both Rockwell Studio 5000 and Siemens TIA Portal offer robust methods for logic encapsulation, but with distinct approaches based on their platform architecture. Rockwell uses a dedicated section for add-on instructions to encapsulate logic and associated data, while Siemens employs functions and function blocks for similar encapsulation of logic, with the added advantage of runtime editing without stopping the PLC. In conclusion, Both Rockwell Studio 5000 and TIA Portal offer robust tools for developing and organizing automation systems, each with unique approaches to program execution and organization, data handling, and logic encapsulation. And if you're just about to get started with your first TIA Portal project, or you simply want to get better at structuring PLC applications, then don't forget to grab my free guide. You can download the guide by simply clicking on the link in the description below this video. There's no better time than now to start your TIA Portal journey. I'll see you on the next video.